Welcome to another beautiful day in Chicago. You're probably watching this on a computer screen right now, so it may not look like this at this moment. Actually, this is from last November. This is another bonus presentation. Yes, the bonuses keep piling up, don't they? Yep, and we still have those bonus noises. We're still looking at LEED V3, but now we're going to look at water efficiency. This section is called water efficiency. We'll go over different strategies to reduce water consumption. Yep, I know what you're thinking. We already know all this, but hey, I just wanted to bring it up again, keep it fresh in our minds, keep it fresh, like fresh water, no pun there. But we'll look at this again before we're done. I hope that your volume wasn't up too loud, and I hope that that didn't hurt you. But that helps to make it more real when you see that. It's another view of the same data, but it's a more dramatic impact, I think. Let's take a quick look at a short video. Thank you, Dr. Sam. My friend, Dr. Sam made that, and thanks for letting us use it. I think I may have caused a little glitch during the playback. Sorry about that. Here's an overview of water efficiency credits. There are a total of 10 points available. Schools get 11. But this shows how those points are laid out. We'll look at it more later. So let's start with WEP1. It's water use reduction. The intent of WEP1 is to increase water efficiency within the buildings to reduce the burden on municipal water supply and wastewater systems, something that is quite often overlooked. To get this, we need to show that our project will use a total of 20% less water than the baseline. 20% reduction in water use is a prerequisite for any LEED. It gets no points, but you need it to get any LEED rating of any kind. If you don't get this, there is no LEED. Doesn't matter how much energy you're saving or anything else, you're not getting it. This 20% does not include irrigation, commercial steam cookers, dishwashers, ice makers, clothes washers, etc. It's basically fixtures. Calculations are based on the occupancy, how many people are there, and what kind of fixtures they're using. And we would include water closets, urinals, lavatory faucets, showers, kitchen sink faucets, and for schools we would include pre-rinse spray valves. Our baseline calcs are based on EPAC 92, which we should all be familiar with by now. That includes 1.6 gallon per flush toilets, 1.0 gallon per flush urinals, 2.2 GPM faucets for residential, 0.5 GPM faucets for commercial lavatories, and 2.5 GPM for showers. Those are the minimum requirements. So that's our baseline. EPA WaterSense standards are different, and they're not required in most places, but some jurisdictions will require it. 1.28 gallon per flush toilets, 0.5 gallon per flush urinals, 1.5 GPM for private lavs, 1.5 to 2.0 GPM for showers, and the other requirements are the same as EPAC 92. So let's look at the implementation. EPA WaterSense is a partnership program sponsored by the EPA. It identifies water efficient products and programs. Each situation must be analyzed separately, of course. Effective ways to reduce water use include: you could install some flow restrictors or reduced flow aerators, some low consumption flush valves, maybe dual flush, install some automatic fixture sensors, which tend to reduce the amount of water used. Be aware, of course, that commissioning and calibration requirements must be considered. Limit or eliminate the use of potable water or other water, natural surface or subsurface water sources available on or near the project site for landscape irrigation. Basically, don't use potable water to water your lawn or flowers. Makes sense. Let's look at some definitions. Wastewater is any water that was used on site. Gray water is untreated household wastewater which has not come into contact with toilet waste. And sometimes kitchen sinks and dishwashers are included in our next category. Black water. Wastewater from toilets and urinals is always considered black water. Surprisingly, there's no actual nationwide definition for black water, but Toilets and urinals for sure. Sinks, kitchen sinks, and dishwashers usually are considered black water. We'll show you why later. Micro irrigation, also known as drip irrigation, is highly efficient form of landscape watering. It's subsurface and has less evaporation. Gets the water to the roots of the plants. Potable water, suitable for drinking. We have some options. To qualify for WEC1, we have two options. Okay, maybe we should say 2.5 options. Option 1, reduce by 50%. We get 2 points. Option 2, no potable water use for irrigation. That's 4 points. Use only captured rainwater, recycled wastewater, recycled gray water, or treated and conveyed. Or path 2, install landscaping that does not require permanent irrigation systems. Temporary systems for plant establishment must be removed. WC2, Innovation Wastewater Technologies, can also get 2 points, as we reduce generation of wastewater and potable water demand while increasing the local aquifer recharge. Tertiary standards means the highest form of wastewater treatment that includes the removal of nutrients, organic and solid material, and includes some biological or chemical polishing. Note that we often hear terms in project meetings and maybe while we're taking an exam, etc., such as primary or secondary standards. These are not as stringent as tertiary standards. WEC2 requirements. In this case, we have 2 options, and this time it's just 2, not 2.5. Option 1, reduce wastewater discharge by 50%. Option 2, treat 50% of wastewater on site to tertiary standards. These goals are not easy to attain either. For option 1, reduce wastewater discharge by 50%, we need to start with fixture selections. These are some options for fixtures. Not all of them are appropriate for all projects, but be aware of them. Notice we have non-water urinals, but we also have non-water toilets. Not for every project. For option 2, treat 50% of wastewater on-site to tertiary standards. Generally need a lot more engineering. This treated water must be either infiltrated or used on the site, remember, so we cannot send it anywhere else. But we can design systems, or we can buy self-contained skid-mounted package systems that are plug and play. For WC2, we need to show that we either have a 100% reduction in potable water use for sewage conveyance, or treat, reuse, infiltrate 100% of generated wastewater on site. So that is not something that we can do for every project, but it can be done, and we have some examples coming up in our sessions. WC3, water use reduction. The intent is to maximize the water efficiency within the buildings to reduce the burden on municipal water supply and wastewater systems for overall building consumption of water. employ strategies that use less water than the baseline. Irrigation is not included, of course. Basically, same strategies that we use for WP1 are applicable to WEC3. Here we want to focus on regulated fixtures in the 1992 Energy Policy Act, or EPAC 92. Lavatories, kitchen sinks, showers, hand wash fountains, janitor sinks, water closets, urinals. Exemplary performance requires that we achieve a 45% reduction in regulated fixture water consumption. That's not always an option, but sometimes we can do this. Sometimes it could even be easy, depending on our parameters. To get WC4, processed water use reduction, the building must have no refrigerated equipment using once-through cooling with potable water, which we don't want anyway. No garbage disposals. At least 4 processed items with water use 20% below industry benchmarks, or as shown here in this example. We need to employ strategies that use no once-through cooling, consuming potable water, which we should already be doing. I mean, it's not even legal in most places. Many systems using processed water in a building may be switched out for high efficiency systems. We can identify industry standards and benchmarks, or justify our own baselines if we need to. And then we can beat them by 20% to get this credit. If we can achieve a 40% reduction in processed water consumption, we qualify for another WEC4 credit, exemplary performance. Not an easy mark, but it can be done. Other credits in the plumbing realm consist of innovation credits, and energy credits, and regional credits. Some energy consumption reduction opportunities include, for domestic water heater systems, we could be using, well, it should be, high efficiency water heaters. We might be using instantaneous, so-called instantaneous or on-demand water heaters, or maybe some solar thermal water heaters. Makes sense to me. Booster pump systems should always have VFDs. You get a soft start, soft stop. Works great. I don't know why you wouldn't include it. Storage tanks are elevated. Also gives you a pressure advantage. And waste heat recovery. So yes, we did mention these things before, but we wanted to mention them again. So, any questions now? Really? Okay. Well, think about it. If you come up with some, we'll talk about them. In the meantime, I want to thank you and look forward to seeing you with another session. Thanks and goodbye.